Welcome everyone. This is podcast number 3. I'm Paolo, the host, and today I have the pleasure to speak to Dr. Shivoh, who is, I believe, in Edinburgh, although he travels a lot. And he's a great engineer. He has been working robotics for some time, and he has a startup, I believe, which is a very successful company now working in safety. And so I'm going to give the stage to you and introduce yourself properly now.
Thank you, Paula, for the invitation and the introduction. Hi, everyone. I'm Shivoh, founder and CEO of Ridescan. Ridescan is like a Fitbit for robots, but the idea is how can we independently monitor these robots to ensure they are safe and reliable when it is deployed in the public spaces and elsewhere. I'm happy to be here and happy to answer questions or discuss things.
Yeah. So is it like a software or a sensor you install inside a robot? Like, can you tell us how does it work roughly?
Yeah, so basically we are deploying these Ridescan agents that can be integrated into the robots that collects the appropriate data from the robot and provides the analytics of the behaviors of the robot doing the tasks, whatever the tasks that robot is supposed to do. And that allows us to get the insights from an independent perspective, and that insights can be useful to the manufacturers as well as the operators of the robot to improve the robot as well as to decide what kind of robots needs to be deployed further or refined as well. In terms of the integration, we have the software package directly deployable, but also if there is like a environment where you cannot go through that kind of a software layer in the cloud, we can deploy as a hardware integration system directly on premise.
Fantastic. And so essentially it's kind of like the equivalent of these anomaly detections, more or less, where you learn the expected behavior, and then if something it's different, you flag an alert, right?
Yeah, so it's how like the humans behave as well, right? There is like the foundation is based on the human computational neuroscience in some sense. So, for example, let's say we have like as a human, you bought like a new home or like someplace, and then you started living there, and then you start to get like that normal experience of how everything is around you, and then suddenly one day somebody decide to put like something else on your chair or replace your chair with something else somewhere. Uh, you are noticing it without any other mechanisms, right? You have like a internal anomaly detection processes constantly running in your brain to actually figure out, okay, there is something changed. And then there is another interesting aspect is like if you have that changed item repeatedly for many days, that becomes like a normal to you as well. It becomes like a self-learning process in some sense.
Yes.
So the other part is that these are like systems that are integrated in the humans, and it is not removed, right? I mean, there is an evolutionary process, and then this is energy consuming, and it is not removed. So that means that there is some use of that kind of a extra additional layer of assessment around us, right? So similarly, we are trying to position that into the robots, but obviously we are not giving back the information, but it is given to the humans. So that layer which it's given to the humans, so that humans will always be in control of the robots rather than
Yes.
um,
Yes. I
sustain.
understand. So, what about practice? Did you actually deploy this in real setup? And what kind of robots have you played with? And
Yeah, I
some
mean,
stories.
yeah, luckily we got a customer in the UK where they are deploying robotic dogs in the enterprise sector. I won't be able to like specifically mention the names, but we have this customer that are deploying robotic dogs, like one of the top robotic dogs, into the areas where they are doing like an inspection and monitoring of that surroundings. And
Yes.
challenge was that when they started deploying these robots, the robot is able to do the tasks. It's able to like execute like what it is supposed to do, go there, scan some things, and coming back home, and it is repeating the tasks. But there
Mm-hmm.
are some incidences where like there could be like small cables on the floor or some minor changes, and then sometimes this robot can drag the cable and
Mm.
continue the task as if the job is completed. So according to the robot, it completed the task. So as per the softwares and everything, like okay, I'm done, like I'm happy and things. But specifically for this customer, this kind of a wire was attached to a very expensive equipment,
Mm.
and feeling everything changed. and,
Yeah.
and and the harder part is that they couldn't figure it out, like was it by the robot or was it by someone else, because robot was not reporting and they had to go there manually inspect to actually figure out, okay, this was actually done by the robot. So
Yeah.
so that actually gave the CTO an easy like decision. So okay, we need to solve that, and then since Ridescan is like a behavior pattern analysis from independent perspective, it's much easier to integrate. And
Mm.
since we have already tested on a like the robotic dogs, it was easy integration as well.
Yeah.
So we deployed the robot. We deployed Ridescan agent into the robot at the customer site, and then we did the trial of collecting the data and then generating the risk score or reliability scoring for each execution.
Mm-hmm.
And we were able to differentiate the good behaviors and then the smaller changes for even for example, like if there is a human that is far, the robot is actually having some influence on those
Mm.
because of the perception changes in the localized environment. So that
Yes.
influence in the behavior was actually captured by the ride scan, even though ride scan is not collecting any sensitive data like the vision
Yeah.
or any.
Yeah, which is quite important. You have to still comply with privacy when these robots walk. I guess they can see people, right? I mean, faces and yeah.
And for ride scan, we don't need that. Like we don't need that kind of information to do the analysis.
Yes. Yeah.
Uh,
Yeah.
that that allows us to access like more enterprise environments without any more compliance regulations and things.
Yeah.
Um,
And how do you see these apply to maybe even like more consumer robotics? Is that something you want to go and like eventually robots in your house or public spaces? Is it possible to apply this technology to make them more safe?
So we are having discussions in this regard, like with multiple robotics companies that are deploying these robots in the malls and in the
Mm.
food delivery, as well as in the yeah, in the hospitals and things.
Yeah.
um, I think this is possible. Like obviously, if the robot is repeating a task and
Mm.
continuously assigned to do that repeated tasks, we can deploy Redscan to make it more quantified, or like basically to make it more to make sure that the robot is always repeating that tasks and what it is supposed to do. So there is no change in the um, extreme behavior conditions.
Mm.
And one more additional part is the since the ride scan is an independent deployment, a neutral layer, that means that if somebody hacks the robot in the public and then it
Mm-hmm.
tries to move into a different direction,
Yeah. Yeah.
um,
Yeah.
there could be a possibility that the robot software itself could be spooked such that they might think, okay, the robot is actually going where it is, but potentially ride scan could be used to capture that variation because it's an
Mm. Mm.
independent layer. But
Yes.
for those kind of deployments, we are also initiating some kind of, some partnership discussions with the sensor company in Japan,
Mm-hmm.
which helps us to like access their sensing unit and API and attachable to the robots. So
Mm-hmm.
that's that's another mechanism by which we can expand to the public deployment robots.
Yes.
Um,
Okay. Makes sense. What is the regulation like worldwide about public safety? Is there anything yet, like in Europe, in US? What, because you have been traveling a lot, right? So you might know what's going on in that space.
I have experience from the direct discussions, but also we did like a market research by one of the University of Edinburgh master's student in politics and in that social sector.
Mm-hmm.
So she explored three segments, like in China, in Europe, as well as in US.
Mm-hmm.
And what she observed was that there is interest in directions in regulations in
Mm-hmm.
three sectors, but
Mm-hmm.
their positioning is a bit different in different geographies. So,
Mm.
but there is a possibility we can unify these regulation standards into a one
Mm.
single core layer,
Yeah.
and potentially Ridescan could help to like combine those into a proper um, like a unified approach rather than diverging in
Yes.
different
Yes.
sectors.
Yeah. Yeah.
So
The last thing we don't want is to have multiple again other standards
yeah,
between countries. Yeah. Yeah. Yeah.
becomes extremely complicated if we diverge in different paths. But I think now there is a progressive um, we can make it like more unified with this kind of standardized mathematical tools,
Hmm?
um, um, potentially like Ridescan, but also more capabilities can be integrated. So I
Yeah.
think the observations was that in the US it was more um, deployment and then thinking about safety.
Classic. Yes. Yes.
And in Europe, obviously, there is more regulatory standards before deployments, and
Mm-hmm.
in China, I think there are continuous deployment standards, but
Hmm.
obviously they are lacking some other structures that I don't remember now. But there
Hmm.
was some challenges in
Hmm.
there as
Hmm.
well. Um, so there is a need for like a unified approach that allows us to like communicate with each segmented, which is potentially, if not communicated well, could fragment in different
Yes.
directions. Um, but obviously, we have seen we can unify in different other technologies, like in the USB and all those, even that ISO standards for other technologies are now standardized globally, right?
True.
So similarly, we can definitely go into these robotic systems
Mm-hmm.
in a more standardized way. And also like the ISO standards are being developed. So there is like ISO
Okay.
4448, which is more focusing on the mobile platforms, mobile robotic platforms in the public, and how it needs to be operated as well. And one thing that is missing is that we don't have like any specific protocols in the robotics, similar to like for example, the OBD.
Two. Yeah. I just
So,
took my car and they were showing me how they take the telemetry. Yeah. So that doesn't exist yet for robots.
yeah, that's
Ah, interesting.
yeah. We need some kind of a unified way to like
Hmm.
access those telemetry and also the black box, right? Like in the um, like in the aeroplanes and everything, like when there is like
True.
a high incident situations, having that kind of a black box which cannot be manipulated is
Yes. Yeah.
really key.
Yes. Yeah. Makes sense. And I think, as you say, it's both forensics, but also in the future, if robots are like cars, you go to a garage hey, I don't know, it's broken, or is it working properly? Like maybe every year you do an MOT for a robot, a COT or a
Yeah,
ROT or something like that, right?
yeah. I think that's a really cool idea. And one interesting thing is that recently, like I think in last month or something,
Hmm.
in China they have started deploying um, ID cards for robots.
Oh, interesting. So you can like each robot is identifiable. You can scan and see. That's a
Yes,
really good
all the
idea.
all the informations about that
Mm.
specific robot, especially that specific robot. That means that the robot manufacturer as well as the where the robot was first deployed, and like all the information about that specific robot is defined in their ID,
Yes.
just like a human. I think that's a
Yes.
really fascinating idea and potentially very
Yeah.
useful as we scale.
Yes.
Um, for claiming and like regulations and everything.
Yeah.
Um,
It's like the registration plate for cars, right? So
yeah,
like
exactly.
I guess well, yeah, stronger as you have a tag that is maybe signed digitally or yeah, some other
Yeah,
systems. But yeah,
yeah, it's fascinating.
pretty
Like
good. Yeah.
there is a lot of progress in every direction,
Mm.
um, and I think yeah, the regulations become one of the important aspects,
Mm.
especially with the AI integrated. I mean, AI integrated robots can make mistakes, right? I mean, I think
Yes.
it's a fundamental um, system flaw in some sense that there will always be uncertainty in the deployments.
Yeah.
So having like a quantified analysis of the behaviors become
Yes.
increasingly important. Yeah.
Yeah, I've seen I mean on social media there are these videos of robots hitting children now that are
Yeah.
becoming kind of like meme, the Unitree slapping children and like I mean, have you seen something like when because you work on this quite regularly? Have you seen any serious accidents yourself or like what do you think why this happens? Is it just the operator wasn't careful or it was a bug in the software? Like what's your feeling? What's your
Yeah. So
opinion?
yeah, I think especially if you are looking at the humanoid deployments, especially those recent deployments, um, they have like a standardized task of that the robot is supposed to do. So it's like moving
Hmm.
around and doing some
A
things.
dance or something like
Yes.
that, yeah.
Yeah, and then there is no fallback mechanism, so it is supposed to do the task without any other.
No matter what, they will keep
Yeah,
doing that, right?
yeah.
Yes.
And then if the feedback is not that high, then they will not stop, and then that can lead to the issues. Yeah, so even if there is an operator, if operator is not fast enough, it could.
Yes, it's going to hit the child or
Uh, Before the industrial robots, they had put it in the cage because they
yes,
know that it's very big and the systems were um, repeating that tasks, but in a very without any
yeah,
like eye or like the things, right? So with the recent humanoids, there is there is some kind of feedbacks that is given, but if it's not good enough or if it's not receptive like it fast enough, then it can have those
yeah.
problems. Um, and it's still not dangerous as it
Hmm.
could be, right? So
Yes,
there
of
is
course.
the
In terms of power that an industrial robot can exert, yeah.
and also, yes, and also the AI integration, right? So even now, when I mention these deployments, they are doing like a repeated tasks. So they
Yeah,
are asked
yeah,
to do flexible movements. If it's a dance, it's like a repetition of a specific steps.
yeah,
But
yeah,
in the future, there will be the robots, which will be much more autonomous. It will be more like go and collect or go and cook food for me or something like that. It's just
mm,
and then cook and come. So if we ask for chicken and if cook something else, that's their alive.
or some expired food, right? They take some yeah.
Yeah, it's kitten instead of chicken could be disaster. So
Yes, yes, yeah, yeah,
So there is going to be more complexities in
yeah. In the
deployment.
safety, yeah.
So safety becomes increasingly important, and I think one of the reasons this is not talked much is because physical AI haven't reached that
No, yeah.
ChatGPT level engagement with the public, and once we kind of reach that threshold of flexibility, I think people will start thinking about
Yeah.
safety, and there is a high chance that, I mean, this assumption, I don't have any claims.
Mm-hmm.
There is a high chance that some small acts or some small or major accident happen, and then people will start to think about, okay, this is
Mm-hmm.
getting out of hands, and then
Yes,
going back to
yes,
the basics. So I think being proactive in these kind of scenarios is better than reactive. And the reason that I started is because I saw those mistakes in the labs, because I was doing the PhD in AI
mm-hmm.
and robots and then playing with the robots. And I could see the robots making stupid mistakes. And it was kind of obvious that it's going to happen.
Yeah.
It's going to deploy in the real world.
In real
And
world.
and the thing is, like, the technology that I saw in the labs, like the reinforcement learnings and reinforcement learning for robots and the world model for robots, that's exactly the way the real world is moving.
Mm.
Like in the US, the billion-dollar companies are being built just based on the world models for
World
robots.
models, yeah.
Yeah,
Yes,
so
yes.
and obviously it's going to make mistakes because of the fundamental limitations of AI. So yeah, it becomes very flexible, but also it comes with a uncertainty.
Yeah, for sure. And another level of risk will be cybersecurity attacks because
Yeah,
obviously somebody can hack into your robot and they can watch you, like if it's
yeah,
in hospital or in the toilet, right? Or they can, they can steal or do any sort of damage, right? That's another level of
yeah,
additional risk, right?
yes, and that's a very important challenge because before we had Roomba, but it was not like very harmful. It can, even if we,
Yeah, I still have one somewhere in my
yeah,
house. Yeah.
yeah, like even if we try to hit, it just comes and like scratch on the legs, right? I mean,
Yes. 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 Yeah.
but if it's like a robot that is going to like cook or clean or like close the clothes or like all the things, it will have much more power in some sense, physical power. So having this kind of a safety mechanisms and safety
Mm.
features will become much more important and urgent in some sense.
Yes.
And remote teleoperation is successful such that it is possible to hack. Right? Like the remote teleoperation can be used in good and bad ways.
Yes. That's
Um,
correct.
and
Yes.
people
Yes.
are people are using in a good way such that you could do the surgery of a
Mm.
person more than 3,000 kilometers away in
Kilometers away.
yeah. And that's actually saving people's life,
Yes.
which couldn't have done. But on the negative side, it could be potentially used in maybe in wars and in somewhere else,
Mm.
and it's bad. So having kind of a separator,
Yes.
separate safety.
Additional layer of security as well. And I know in cars they're doing something similar in US where I can't remember which brand, but they have the actual remote drivers that can either jump in when the car maybe is on lost track, or and they can remote in and say, okay, I need to unstuck this car,
Yeah,
or but at the same time, yeah, what happens if some maniac gets
yeah,
control and go and kill someone on the street, right? It's possible, yeah.
yeah. I
um,
think it's I think it's possible, but it can also be prevented.
yes, yes, for sure, for sure.
So yeah, I think those are the challenges. I think in the physical AI world that as we progress,
Mm, mm, mm,
um,
mm.
and
Yes, I mean, we have seen nothing now. We have all these cybersecurity attacks or injections to LLM models. And
yeah,
now we are moving to physical. It's like 10 times more difficult, right?
anyway,
you can compromise the text to speech, or the kind of verbal, because maybe you can convince him to do something now, right?
Mm.
um, but then you can also hack him, right? You can get into the telemetry, yeah, control
Yeah,
the actuators.
yeah.
There's so many things you can. Yeah,
If you have access to the control system of the robot, and spook that, yeah, I mean, there is a lot of
yeah,
possibilities.
yeah.
Just that it shouldn't be given to the bad users.
No. So you will have a lot of work to do with your company, right? There's so many, as this grows and gets into mainstream consumer, you're going
Yeah,
to have a lot of things to do.
yeah. We are like, there are mechanisms in the Ridescan itself to make sure that all those kind of issues are
Mm,
prevented from my side. And the other part is
yes.
that a we are not controlling the robot, so we are only like
Yes,
a,
that's true. Yeah, you're passive monitoring, so yeah, there's nothing can really go wrong in your case.
yeah, we cannot like influence any decisions of the robot. We are just
Mm,
passively providing advices to the operators and
yes.
the end users.
Okay. Good. So a few final questions before we close. Since you have been working with real robots, you have seen them in real setups and deployments, and we see a lot of these fancy demos that look very good, like folding clothes or cooking, and like fortunately, if you look into details, they are very cherry picked. Like they don't seem to be deployable. But of course, there's been a lot of progress. So, what is your feeling? Just as an expert, to see how long we will see these deployed, like a humanoid that can last one day, so he has enough power and energy to work one day. Then he goes to
Mm.
sleep to recharge, and
Mm.
can do some of your basic tasks. Like trash the rubbish and do some cleaning. Like, do you think it's 3 years, 1 year, 5, 10? What's your?
I think it will take a minimum of 5 years,
Yeah.
at least. Even then, I don't think with the current technology it can be as
Mm,
generalized as possible. Even if we generalize, there will be like a calibration phase once you get into a new home, and
mm,
depending on how well you calibrate, it could be good or bad. So there will be like more kind of jobs that is coming up with this kind of setting up of the robot, like troubleshooting and all those
mm-hmm.
problems that come with that. Even in that scenario, there is the business model risk, right? Like you are essentially trying to replace whatever work is being done by somebody else. And if it's a unit economic problem, like if it's not worth to replace, nobody
True.
will replace.
Yeah.
So
Yeah.
it's like,
Economies of scale, and yes, it makes sense. Do you think it will become like the equivalent of laptops, and you install software for doing, like, you buy a laptop like from an OEM, and then you adapt it, and like, yeah, this is my version, and you
yeah, I
can do
think
certain, yeah.
I think that's possible. And if you look at the Unit 3 is one of the top humanoids now, right?
Yes.
And so like they have like a app,
Okay.
like, so in the app store, it's like a Play Store, and you click on the whichever tasks for that role, you just download it and do it. It's getting that in there as we.
Okay. Okay. I guess it makes sense, so that you sort of do it in that way. Yeah, makes sense. And
And
yeah, sorry. And so, like, do you think the hardware is mostly solved, or we still have to do like more powerful motors, but safe, like more autonomy, like the battery lasts only 1.5 hours,
I
depending on the
think,
robots. Yeah.
yeah, I think there will be continuous iteration of the hardware, similar to the phones. Like there will
Mm,
be like performance optimizations, and also like if we are able to like decrease the cost to more and more to the like the standard user acceptable cost, it's going to be like a game in that
mm,
sense. Once we crack that, then adoption will follow. I think the harder part is going to be the software because generalization as well as human like user experience, right? If it's only programmable by a roboticist, then it's going to be
Yeah.
very less adoption.
Yes. Yes.
So
Yeah. Yeah.
there's like a software element. Yeah, there's a lot of excitement. I mean, I'm really excited about the physical AI, but I don't
Yeah.
think it'll happen in like 1 or 2 years. It'll,
Okay. Okay. So it's kind of like for you a slow game, and being there to build the foundations
yes,
for yes.
yeah, we need to have like that neutral infrastructure layer on top of these robots, because at the end of the day, humans should be in control, like no matter how autonomous it becomes. And the only way we can do that is by having this neutral layer. Because I was recently hearing about like a Deloitte talk, which was and one of the key insights were like we are moving towards this human in the loop systems to the human on the loop systems.
Mm,
And I think Ridescan is more towards the human on the loop
on the loop.
rather than in
Yes.
the loop. Because
Yes.
if you are always in the loop, then things cannot be automated. But if you are on the loop, still humans having control,
Yes.
but let the autonomous systems
Yes.
do whatever it is needed to do. So
Nice. Yeah, I like that. In the loop, over the loop. Yes. Yes. Makes sense. Makes sense. Great. Okay, we are almost done. Well, thank you for this chat. I'm going to put your website and any other links down in the comments below so people can reach out to you. Hopefully, we can do another one. If you have any updates in a couple of months, you can talk about things that you're developing. Good. Okay. Okay, have a nice day. See you next time.
Bye.